What does inverse mean? Well, let's take a look. We're going to be looking at the additive inverse and the multiplicative inverse, which is a fancy way of saying inverse for multiplication. All right. Additive inverse is the opposite of a number. The multiplicative inverse is the reciprocal. Right? So when we're talking about the opposite of a number, picture a number line here. For every positive number, there is an opposite, being the negative, right? The opposite of a negative number would be a positive. So these are opposite numbers here, or additive inverses. A reciprocal you could think of as being the flipped form of a fraction here. So if you had 3 over 4, the reciprocal would be 4 over 3. Now 2 is 1/2. And again, always kind of remember those invisible ones, right? So if I have the number 2, I could write that as 2 over 1. The flipped form of that fraction would be 1 over 2 then. All right? So, right, opposites, if you have a x plus its opposite here, right, these two numbers 0 to any number, it's just itself. So these are additive inverses because when you add them together, you get 0, and 0 is a number that, when added to anything, it doesn't change the value. Like reciprocal, right? So when you multiply fractions, you go across, and you would have 3 times 4, which is 12, and on the bottom you have 4 times 3, which is 12. Any number divided by itself is just 1. So when you multiply by the reciprocal, you get 1, and 1 is a number that when you multiply it, it just gives you the same value, right? So this is why the reciprocal opposite numbers are the additive inverse. Let's look at some more examples of this. All right, additive inverses. These are all one-step equations that we're going to solve using the additive inverse. If you have a subtraction sign, I want you to change that to plus a negative, right? That would be the same as subtracting 4 here. Now, when solving an equation, whatever you do on one side, you do to the other. And we are going to add the opposite. If I have negative 4, I'm going to add the positive 4, and I do the same to each side. Negative 4 plus 4 is 0. So I could write this as x plus 0 equals 10, but anytime I add 0 to a number, it doesn't change the value. So this is just x equals 10. Likewise here, I have a positive 4. So we're going to add the opposite. Now I'm going to add a negative 4 to both sides. I like to draw these bars just to keep the two sides separate. So again, 4 plus a negative 4 would give me 0. Right? Now I have 6 plus a negative 4, which is 2. Right? So x equals 2. Since if I add 0 to x, it doesn't change the value. Now, you could have the variable come second like this, right? You're doing the same step by adding the opposite. So it doesn't matter where the variable is. There's only one operation being done to the variable. So we're doing the exact same thing we did here. This equation just looks a little bit differently. So now I'm just going to write x equals 2. I'm not even going to bother writing the 0 there because I know that 0 plus x is just x. Likewise, all of these have the variable on the left side. You could have the variable on the right side. Same idea though, right? We're adding the opposite to both sides. So this is an equation where the x was on the right side and that you still do the same step and solve it like the others. The x is just on the right side. So that was the additive inverse. For the multiplicative inverse, we're saying that the multiplicative inverse is the reciprocal, or the flipped form of this fraction, so 5 over 2. And again, what you do on one side, you do on the other. And I like to draw these bars. So when you multiply fractions, you multiply across, right? So here I have 10 over 10. 5 times 2 is 10, 2 times 5 is 10, right? And keep in mind, I can always write this over 1. So my numerators are 2 and 5. That's 10 over 2, right? Now, this would simplify to just be a 1, right? And 1 times x here is just x. 10 divided by 2 is 5. Right? Now, I could divide here, which would be the opposite of multiplying, but I'm going to stick to using my inverse. And the inverse of 2 is 1/2, because again, I can think of this as 2 over 1. I'm going to multiply 1/2 times 2, because this is the reciprocal. When you multiply by the reciprocal, you just get 1. Again, I'm going to draw my bars here to keep my two sides separate. Here I could think of it as 8 over 1. We're just multiplying across. So you get 8 times 1 is 8. 1 times 2 is 2. So we're going to simplify this. I don't need to write the 1 because that doesn't change the value. I just have x. 8 divided by 2 is 4. All right. Now, here I see x is divided by 2, right? That is the same thing as saying as if I had a 1/2 x, right? Because again, I could always think of this as a 1x, that invisible 1, right? So if you're dividing by a number, we're still going to multiply by the reciprocal, which in this case is 2 over 1. Right? So 2 over 1 times the 1/2, that's just a 1. Right? Multiplying x by 1 doesn't change the value. You just have x. And our denominators here are just 1. We're multiplying across, 8 times 2. I'm just going to write 16. I could write 16 over 1, which is the same thing as 16. All right, here we see I'm going to multiply by the reciprocal, right? The flipped version would be 3 over 1, which is the same as just saying if I'm multiplying by 3. So hopefully you see now that if you have a number like 2, you could write that as 2 over 1. If you're multiplying x by 1/2, the reciprocal you could write as 2 over 1 or think of it as just 2, right? Same thing here, right? So on this side of the equation, I just get x. 9 times 3 is 27. Right? So these have been some examples of to solve one-step equations. Thanks for watching.